very nice conceptually, and I'm getting something. But what is the concrete mathematical thing that I have now that I didn't have before? What am I doing better than I didn't do before? So I was talking about this with my colleague, Oleg Davidov, who's another spline person, and we were trying to think, this was straight after Larry's lecture, what should we do? So of course, neither of us wanted to work on it in isolation, so we persuaded a student to work on it. So that's kind of the background to what I want to talk about. So now my original abstract is kind of the latest stuff I was doing, and I kind of started to put that together, and I realized that I was assuming you knew all of the stuff we'd done before. Now, while I'm sure everyone's read everything I've written chapter and verse, I'm not convinced that's the case. So I do want to go over kind of the ideas that led to that. So I'm going to review a little bit more. I'm speaking to the converted, talking about Bernstein Bezier polynomials here, but I still want to talk about them from a finite element point of view. And then I'll talk about what I call the sum factorization algorithm and this AED algorithm and so on. But this is really a rough outline. So this is primarily work done with a student, Gail Andriamaro, in collaboration with my colleague, my ex-colleague at Strathclyde, Oleg Davidov. So let's get some nomenclature straight. So basically, what we've got is, here I've just drawn a triangle, and then I've got these control points. Finite element people would call them nodes. So there's my element. I've got a set of multi-indices which tell me where these nodes are. So multi-indices and domain points. So the domain points are obtained by taking linear combinations of the nodes with the weights taken from the multi-indices. And that generates this lattice on the triangle. So everything I say will go through to d dimensions. It's not going to be 2 or 3. Most of my pictures will be in